In our development of consumer theory, we also showed that non-convexities might give rise to multiple optimal solutions being offered by the calculus method, with only some of those solutions being truly optimal. We'll illustrate the same thing here for producer theory. We begin again with our usually shaped production frontier, a little exaggerated here. Suppose, for instance, that the prices and wages are such most clearly that there's an isoprofit that's tangent to the production frontier. Prices and wages are such that there's an isoprofit that's tangent to the production frontier. The kind plan A. That method will indeed return the calculus method plan A focuses on as a possible solution. Kind. That method will indeed return production plan A as a possible solution. In other words, when we solve the maximization problem, one of the solutions that we'll get is that we should use LA in labor to produce XA in output. But there's another isoprofit with the same slope that also has a tangency with the production frontier. That's the magenta one here that is tangent at the production plan B. Since the calculus method provides us with all tangencies, it'll also return production plan B as a possible solution. When production functions have this shape, the calculus method will therefore usually provide us two solutions, one that looks like A and one that looks like B. Obviously, the one at A is in fact the correct profit maximizing solution. It results in positive profit, as indicated by the positive intercept of the isoprofit line, whereas B results in negative profit, as indicated by the negative intercept of the magenta isoprofit line. One way to select among the solutions that's returned by the calculus method is to simply plug the production plans back into the profit function to see which yields a higher profit. Another way is to simply use your intuition. If you know the underlying shape, roughly, then you know that the production plan with more labor and more output is in fact the profit maximizing one. This possibility of two candidate solutions being returned by the calculus method is not a possibility when the underlying producer choice set is convex because of a concave shape for the production function. In particular, for any W and P that we pick, in other words, for any slope for the isoprofits that we pick, there'll only be a single isoprofit line that's tangent to such a production frontier. We can then combine the insights from graph 11.12 with the insights here. If we have a production function that gives rise to the production frontier that has an initially shallow slope that gets steeper and steeper, but eventually gets shallower and shallower, then the calculus method will typically return two solutions to us. One solution will lie at a tangency where the profit is definitely negative, a tangency like that at point B in our graph here. A second solution will occur at a point like A. That point might have positive profit, or it might have negative profit as it did in graph 11.12. We therefore have to be careful about how we interpret the solutions that are returned by the calculus method. We know at least one of them results in negative profit and is not a true profit maximizing production plan. The other might be a true profit maximizing production plan if it results in positive profit, but if it results in negative profit, the true profit maximizing production plan is a corner solution.